Hello, my fellow practitioners, API practitioners. Today I will give a presentation about API architecture and how we use API architecture for Microsoft Graph. So a little bit about me. My family moved to US almost 25 years ago. And I've been working as a developer, as an enterprise and architecture, as an enterprise integration architect. Also, I led a cloud adoption program in my previous roles and have multiple certifications. My role right now is Principal API Architect for Microsoft Graph. I'm very lucky to work with a very bright team who you already heard before today. I'm working with Garrett, Brian, and Daryl, who is not here today. So now you know a little bit about me, and the plan today is to talk about Microsoft Graph APIs and how we use architecture method for API governance, and also how we define API quality criteria for our APIs, for Graph APIs. So a little bit about Microsoft Graph. Microsoft Graph is the main API, unified API surface for M365 SaaS products. It includes many well-known products such as Outlook, Teams, Exchange, Azure Active Directory, and many other new products coming on board. Microsoft Graph has more than 3,200 addressable resources. And we constantly have new teams bringing their products on board. But Microsoft Graph is not only REST API. It's also very rich ecosystem of developer resources. It provides playground, testing playground, discovery playground for developers. It also provides various SDKs in 8 languages. It provides PowerShell and CLI commandlets. And it provides rich documentation covering almost entire surface of Graph. You can see that we have tremendous amount of usage on our platform, and it definitely brings challenges for the scale of this platform. When we look at Microsoft Graph from inside, we see that more than 120 different teams delivering their product to Microsoft Graph. And we have 3 different review boards in 3 different organizations to support all these Graph APIs. We have more than 800 reviews over a year, and we deliver various enhancements, new APIs, new features to Microsoft Graph surface. So with this scale, as with continuous growth, what we face a problem. How to scale it further? And basically how to think about APIs. What does it mean a good API for us? Traditionally, and we talked a lot at this conference about API design. Traditionally, governance focus on API design, on consistency of naming, consistency of shape, consistency of behavior. And we recently asked questions ourselves, is it good enough for us? So this is the main question. What is a good API? It seems a very simple question, but it's a strategic question for us because it let us prioritize our work. It let us to lead compliance with our criteria. It also helps us to delegate API work. We decided that we will use consistent architectural approach to find an answer for this question. And today, the purpose of this presentation is to show a little bit of this inside work, how did we try to find the answer and what the answer is? Let's talk a little bit about software architecture. So software systems are not created just because all of us love it, though I know that we, especially developers, and we as developers really like creating software products, but they created to address organizational roles, to address business goals. And from this perspective, APIs are not exceptions. APIs are created to deliver business value. And we can think about architecture as a bridge between delivering business goals and designing final software product. And quality attributes of a software product actually are pillars of this bridge. So architecture is an abstraction by nature, and it's based on creating a model of the system which we're trying to produce. These attributes of the model are usually called architecture significant requirements. Architecture significant requirements are those requirements which produce profound effect on the system, and they are very often presented as quality attributes. What are quality attributes? It's many different ilities such as availability, maintainability, usability, and other ilities of a system which you may define. A good example would be, imagine you need to buy a car. You need to buy a car to commute to work, drive kids to school, go shopping, and any other purpose. This would be a functional requirement. When you think about car performance, such as how fast it accelerates, or what is the mileage per gallon, or how smooth is the ride, then you probably, this would be quality requirements for an architecture. And when we think about the car, additional very interesting perspective, like how much does it cost, and what is the warranty, what is the resale value, would be a good representation of organizational constraints, which also serve as the requirements and have impact on the software product. So as we understand what are quality requirements, architecture method gives us a tool to derive these quality requirements from business goals. Basically, it's saying that it's a role of an architect, it's responsibility of an architect to understand business goals and derive quality requirements, and quality requirements will define software product. So from this perspective now, we just need to understand what is the business objective of our organization. Let us take example of Microsoft. At Microsoft, we take customer-driven culture very seriously. And today we already heard this message from our panel that customer perspective is extremely important for success of APIs. So from Microsoft Graph, we think about what customer value we will deliver for our consumers. Since Microsoft Graph is a big programmability surface on top of M365 products, we think that customer value is to build innovative business solutions which extend productivity communication tools Microsoft provides. For example, customer value would be to build a healthcare application which takes usage of Teams communication channels and meetings, or build enterprise portal and take advantage of line of business websites created on SharePoint and taking care and easily implementing workflows based on the Power Platform. From this perspective, if our customers are building business solutions, it means that they need to have reliable, resilient, and predictable APIs, supported throughout entire life cycle. And for us, it means that our customers need to have API as a product, so that we would support entire life cycle of APIs consistently. Therefore, since we established that our customers expect our APIs to be software product, we can start applying architecture method to deriving quality attributes of this software product. So from the perspective of APIs, we know that it's not just a software product, it's a cloud product. And we have many well-known established frameworks like AWS, Azure, well-architected frameworks. These suggest to use a predefined set of quality attributes such as security, operational excellence, performance, and availability. So we have a foundation. We will start from this set of qualities, which we can use for API as a software product. On top of it, we also need to consider our organizational drivers. And our organizational drivers, for example, at Microsoft right now, we focus on supporting APIs throughout its entire life cycle, on predictable releases, on knowing roadmap of features. So we're focusing on planning as a quality attribute. In addition, for our customers to adopt APIs, they need to have full documentation coverage, and it's a great part of the usability. So if we focus on usability as a very important quality for our organization. In addition, because of the uniqueness of APIs, design is essential for APIs, and we promote API-first design, even though not all of our legacy products right now follow this principle. Many new products start with API-first design, because API-first design promote modeling of information flow, promote modeling of and understanding of actors of the system, and ends up in more user-friendly APIs. So as we established these 6 foundational for us quality attributes of API software product, now we need to socialize and communicate to all of our teams across Microsoft what is our framework, what are requirements of this framework. As you know, we have a lot of teams working on APIs, so verbal communication for us is not an option. Therefore, we started looking at a better description of our requirements. We are not starting from scratch. In 2016, we have Microsoft REST guidelines written and established, and it was a great foundation for internal teams and also provided best practices for entire industry. But as we have more and more cloud-specific, cloud-first products such as Azure and Microsoft Graph, we have very specific new patterns and new requirements. And we created a new set of guidelines specific for Graph. So it's focused on consistent naming conventions, consistent shape and behavior, and also on very strict constraints on breaking changes. We do not allow breaking changes. We basically have a promise for our customers that our APIs will be stable and we support deprecated features for at least 2 years or 3 years. In addition, we focus on specifics of modeling for graph, and all these specific features we described in graph guidelines. We also decided to build reusable building blocks for our designers, and we call them library of patterns, library of design patterns. Again, we used a well-known architecture pattern language, which is comprised of basically, if you have a problem, there is a particular solution in a specific context. In this way, we created a very short, actionable documents for our developers, for API developers, how to solve API design problems with a lot of examples, which they can read for like less than 5 minutes and apply to their design. As we documented our requirements, we also need to ensure that all APIs are compliant with our quality requirements. And we have 3,200 of APIs, and every week we have changes, new enhancements, new updates, new APIs delivered on board of Graph. It wouldn't be possible without automation. Onboarding so many APIs and supporting their lifecycle and supporting compliance at every step of the lifecycle wouldn't be possible without automation. So what we did, we have automation across entire lifecycle, starting with planning, and it goes long way for internal and external developers. For internal developers, we provide API search and discovery. We support generation. We support generation of documentation stubs. And for external developers, we support generation of SDKs and CLI and PowerShell commandlets, and also support verification of documentation. So as you can see, each step from planning has multiple features which we automate and integrate into the pipeline. Pipeline itself actually is based on Azure DevOps pipeline, which orchestrates the entire workflow, ensures that all approvals are basically achieved in time, and has integration during planning with internal and external roadmaps, has integration with linting tools. We're also working actively with Azure team on implementing CADL domain language to support design, automation, and promoting design patterns and design verification at the very beginning of the pipeline, shifting left. And we're working on active document. We already implemented significant portion of documentation testing, permission testing during implementation and onboarding. Very important part of our API ops pipeline is security. Even though on the picture security is as a standalone kind of columnar feature, security is essential at every phase of API lifecycle. So we start with designing security authorization permissions along with designing domain model and model for the API. Then security is expressed in similar language as the API design description. It also we also provide significant verification for permission testing during onboarding, and we ensure there is no conflicts for authorization permissions when APIs come to Graph. In addition, in production, we consistently monitor for least privileged posture, and we provide reports if permissions are overused or too high. During operations, to support operational excellence, we have tracing and monitoring and logging in place. And what is extremely important for Graph, that logging supports all compliance requirements for US and European Union GDPR compliance. So we went a long way with automation. Now what is the next step for us? How do we know that we achieved success? If we achieved success, we need to provide quality observability. And what do we understand by quality observability? As we defined what are our qualities in our definition right now, it's 6 quality attributes: planning, design, security, operational excellence, performance, and availability. For every quality, we have a KPI. KPI is basically an important metric, how we try to understand that this particular area of quality is successful for an API, and also it's metric which promotes positive outcome. Probably all of you know that what we measure sometimes may inflict totally different results that we expected. So we designed our KPIs the way that it encourages outcomes we expect APIs to have. For example, for planning quality, what we want to have predictable releases, because our customers want to know when new features will be delivered. Therefore, we decided that we will measure how long API stays at test and that it's not stale in test. This is a temporary metric. We use it for now to promote the best outcome for the current phase of our journey. For design, we measure linting exceptions, deviations from standards, because our design and linting exceptions are intended to make our APIs more user-friendly, and it's what we want to achieve. Security KPIs are still in progress. Right now, we're still working on them, and I won't cover them. For operational excellence, for example, we know that we want to deliver great APIs across all clouds and across all regions of Microsoft Graph. Therefore, we measure cloud parity for our APIs. And finally, for performance and availability, current KPIs are existence of service level objectives. Unfortunately, we not always have very well-defined service level objectives for APIs. And it's understandable because many of our products are legacy products, and they have their own SLOs and SLAs, and APIs as an afterthought. So we need to focus on how APIs themselves perform, because APIs add additional layer of interaction on top of the entire architecture. So we need to ensure that they know their SLAs and they design accordingly. So where we are in our journey right now. We have not started from scratch, and we still working we're still at the beginning of our journey. It's a continuous improvement, but what we observed so far are very positive results. First of all, we see very significant positive result on our reviews because they are getting faster and more productive. Our customers, our API developers actually, using our patterns and know how to reason about a solution and what solutions are, what design solutions are good solutions for a particular problem. In addition, we have a total mind shift in organization from the perspective of understanding API as a product and understanding that APIs need to be supported through entire life cycle. API development teams are taking ownership of their APIs across the life cycle. Additional big advantage is that APIs are better aligned with their quality attributes. It means that when API developers know about performance SLOs upfront and think about achievable performance, they basically can design APIs differently. They can select is it synchronous or asynchronous API, shall they use a long-running operation pattern, and they can reason about design decisions much better. And additional achievement we have that API quality now is a common understanding, and also it's evaluated at every stage of the life cycle of API. So the main takeaways I hope you will get from this presentation are: first, APIs are software products. And when we treat APIs as software products, we need to think about full life cycle of APIs. We also can think about API quality attributes, which are derived from your organizational goals to define your API software product. When we think about patterns and reusable building blocks, they are a great help in the API development lifecycle, in the API development process. And also, at scale, automation API ops are essential to deliver great APIs and verifying API quality attributes consistently. And at the end, to understand how successful you are with all these endeavors, you need to have API quality observability. And the most important conclusion I made for myself a long time ago is that architecture is a bridge. And it's a bridge between organizational goals and quality software product, quality API product. Thank you so much for your attention. This concludes my presentation. And if you have any questions, so it's time to ask questions. Sure.
Thanks for your presentation. I have two questions. Do you have can you share a repo where you're implementing the API ops pipeline? So you can share an example, code example.
API ops pipeline is implemented in our internal Azure DevOps. It's not public. No, I cannot share it. Yeah, it's.
And also, I know about the API ops lifecycle, and that's something that maybe I think maybe if you can clean it up a little bit, you should reconsider that. Maybe help out the community to say there's a thing as API ops, and here's an example of that, just like documentation, etc. So maybe you could talk to Daryl and figure something out. My other question a developer who is focused on delivery to treat whatever it is that they're building, in this case, we're talking APIs, how do they treat APIs, like the first point? How do you get them to understand that, hey, you're building, that you treat your APIs as a product?
We start with communication, socialization across the entire organization, and basically what we are trying to do. We're trying to present this API quality framework consistently at the very beginning of the process, of the design process. We explain that API starts with understanding of domain model with full life cycle of API, and it's, as I said, mindset shift in the organization, starting from customer value, thinking about customer value and business value, about designing to achieve these values, and supporting it continuously during the life cycle. We just continuously deliver this message, describe it, and basically implement it in our everyday practice, in our everyday review processes, and yeah, that's how we do it. Thank you for the question. Yes?
So you mentioned about the library of patterns, right?
Yes.
Is it available for satisfying purposes?
Yes, yes. So our version of Microsoft Graph Guidelines is available, and if you go to AKMS Graph Guidelines, then you will be able to see our guidelines, summary of guidelines, and also library of patterns. Yep.
So does all the teams in Microsoft come for an API design review before they start the implementation? Do they come to your team?
Exactly. Yes. So we have, as I mentioned, we have a slightly different flavor for Azure, a slightly different flavor of specifications, and all organizations which are on Graph, which also multiple organizations and multiple products, M365, Azure Active Directory, they all start engaging with us very early in the process. And I'm talking about API review, but actually API review, it's a final gate in the process. We start with consultation, and we start with designing APIs with teams. We promote API first design, means that we ensure that teams understand domain model, existing and future use cases, existing interactions with actors, external actors, external customers, and also information flow. So this design process, we start very early. Thank you. Any more questions? Thank you.